Let us go to another theorem, and in this theorem the proof which we use is called an indirect proof. That means we have two types of proof, direct proof and indirect proof. The direct proof was a theorem where we used just earlier, that is the opposite angles formed by two intersecting lines are of equal measures. There we use the direct proof, and here we will use what is called as the indirect proof. I will tell you and explain to you what exactly is indirect proof as we go ahead. Now in this theorem, the statement which is given to us is a prime number greater than 2 is odd. Now very clearly to you, you must be able to understand when we are stating this statement, that is a prime number greater than 2 is odd, it is not a statement of geometry. It is just a statement which we are supposed to prove. So therefore we won't have a figure here. Okay, now once a statement is given to us, we convert it into a conditional statement. Now when I convert it into a conditional statement, how do I convert it? I consider a prime number. Say suppose I take P as a prime number. So if P is a prime number greater than 2, then it is odd. Okay, so I'll write the conditional statement. If P is a prime number greater than 2, then it is odd. Okay, so this is a conditional statement. Is it a conditional statement properly? Yes. In a conditional statement we have to have if and then, both are there, and so we have the antecedent and this is the consequent. Okay, so now we have to write the first step in a proof. What is it, the first step in a proof? To write given. What is given to us? P is a prime number greater than 2. Okay, so this is the first part. So I write given P is a prime number greater than 2. Now if P is a prime number greater than 2, a prime number has only 1 and itself as the divisors. Now the number is P, okay? The prime number is P. Therefore 1 and P are the only divisors of P. So if we say P is a prime number greater than 2, then 1 and P are the only divisors of P. So we have completed what is given. Now we have to write to prove. Now what will be to prove? If P is a prime number greater than 2, then it is odd. That means we have to prove now that P is an odd number. So what do I write in to prove? P is an odd number. So this is done. Now next is the proof. Okay, so we write down the proof. Now, what had they given to us? That P is a prime number greater than 2. Okay, P is a prime number greater than 2. Now, and they said then it is odd. Now, although they have said that if it is a prime number greater than 2, then it is odd, and we know that it has to be an odd number. What we do in an indirect proof is, what we are supposed to prove, we say it is the opposite. Like here we have to prove that P is an odd number. So what we say in the beginning in an indirect proof is, let us suppose that P is not an odd number. Let us suppose that P is not an odd number. We have to prove that P is an odd number, but in an indirect proof, what we do? We say just the opposite of what we have to prove, that let us suppose that P is not an odd number. If it is not an odd number, what type of number it should be? The opposite of odd is even. Therefore, P should be an even number, right? So if it is an even number, which are even numbers? 2, 4, 6, 8, right? And in 2, 4, 6, 8, what are the divisors of these numbers? Common divisor for 2, for 6 and 8. 2 is a divisor of every even number, right? So therefore 2 also is a divisor of P. So we number this as 1. But in given, what have we said? Look, in given, we have said 1 and P are the only divisors of P. Did we write 2 also here? No, only 1 and P are the only divisors of P. So we write, but in given, we have mentioned that 1 and P are the only divisors of P. So here we are seeing, according to our proof, that 2 is a divisor, 2 also is a divisor of P, but in given we have 1 and P are the only divisors of P. So if you look at statement 1 and statement 2, can both of them be right? No, because here 1 and P are the only divisors of P. First only they are given to us. Can we add by ourselves that 2 also is a divisor of P? No. So that means statement 1 and statement 2 are contradictory. That means they are disproving each other. So we write contradictory. Contradictory means one is disproving the other. That is, 2 also is a divisor of P is contradicting this statement. So statements 1 and 2 are contradictory. Therefore, the assumption that, what assumption? That is, we assumed that P is not an odd number. This suppose means it is an assumption. So let us suppose that P is not an odd number. Therefore, that the assumption that P is not an odd number is false. Hence, if P is not an odd number is false, that means what should be true? P is an odd number, right? So, hence, P is an odd number. Okay, therefore this proves that the statement what is given to us of the prime number greater than 2, then it is odd. Therefore, we can prove that if P is a prime number greater than 2, then it is odd. Once we said that P is an odd number, that is what we had to prove, not to prove P is an odd number. Therefore, because if we consider any P a prime number greater than 2, then it is odd.